So today we're going to be graphing secant and cosecant waves. Now these are the first reciprocal functions that we're going to be graphing in relation to their normal trig counterparts. And the first thing you're going to notice with a secant and a cosecant wave is we're going to be having a lot of asymptotes going on that we don't normally have. The only asymptote we've encountered so far are going to be with tangent waves. Secant and cosecant waves are going to have just as many amplitudes, and we're going to see how they work together with their normal trig counterparts. So where those asymptotes come from is, let's take a look at what the counterparts are based off of. What we see is that cosecant is based off sine. We know it's the reciprocal of sine. So I know sine is normally opposite over hypotenuse, which means cosecant is going to be hypotenuse over opposite, which on the unit circle, opposite of a triangle is going to be the y, the adjacent is going to be the x, and the hypotenuse is going to be the radius. So for the cosecant, I'm dealing with the radius over the y value. And so we know that the y value, unlike when we had it originally with sine, the r value, no matter what, always had a value, no asymptotes. Here, I'm going to have an asymptote every time that y value hits 0, which means at the start, at 0 and at 180 degrees, if it's a normal secant or cosecant function, we're going to get an asymptote. The same thing is going on with our secant function. So if I have a cosine, I know that's normally adjacent over hypotenuse. The secant is going to be hypotenuse over adjacent, which again, on a unit circle, hypotenuse is going to be r, and the adjacent is going to be x. We're going to have plenty of values on the unit circle where that x is at 0, namely at the top and at the bottom. The x is going to cancel out and leave our function undefined. So let's take a quick look at the first one to see how we're going to use those first trig counterparts to graph these reciprocal functions. So number one, I have the cosecant of x. Now a cosecant, its buddy is going to be the sine. And we're going to use the sine in order to graph the cosecant. Not exactly sure how. Well, just stay with me and we'll see where this goes. So I need to dictate what is the amplitude, what is the period, and whatever shifts are going on. Now the amplitude on a sine wave would be easy. It's going to be the value in front. It's 1. Cosecant's going to be a little different. The period is going to be 2 pi over b, which in this case is just going to be 2 pi. So nothing different here, but this amplitude is going to be a little weird. So what we're going to do first is I'm going to graph a sine wave with these basic characteristics and see what we get. So before we even graph the cosecant, let's graph a sine wave. Well, I know the sine wave repeats itself every 2 pi. I know that directly between pi and that, it goes up and curves down. And then directly between these 2 points, it goes down and curves up, and boom, we have a period. In fact, this just keeps doing that same pattern where it curves up and curves down. And boom. So we have ourselves a sine wave. Now, this is going to be how we set up our base for our cosecant wave. Now, there's a couple things we need to pay attention to. At pi, 2 pi, 3 pi, 4 pi, and 0, all these values where my sine wave is 0. My sine wave, if we remember, is going to be my opposite over my hypotenuse, so 0 over something. If I flip that and put something into 0, I can't put anything into 0. So that means that at each one of these 0 values, I'm going to end up with an asymptote. Because if I flip it, I can't put something into nothing. So I have these 4 asymptotes. And let's swap over to purple. The next thing I'm going to pay attention to is that at these maximum and at these minimum points, I have something special that happens. At the maximum point, what I'm dealing with is let's take a review quickly at the unit circle. So I have that. At the maximum point, what I'm dealing with is the sine wave right here, where let's see, with sine wave, we're dealing with y over r, which is y over r. Y and r are both the same thing. They're both 1. If I flip that upside down, they're both 1. So I know the reciprocal is also going to be at that value. The same thing happens down here. Way down here, when my y and my r end up being 1 over 1, but it's negative, my flipped version of that is also going to be 1 over 1, but negative. So I know that the graphs touch at these maximum and at these minimum points. The only thing that's going to be different is what is the shape between those points and the asymptotes. Now, if I were to take any point on the unit circle, let's say between 0 and that maximum point, let's say right here, I know that as it's creeping up, what's going on is that we're dealing right here. I'm approaching the 1 over 1, and if I start way down here, I have something very, very small over 1. If I invert that, that something very, very small over 1 is going to be 1 over something very, very small, which is going to be very, very big. So this graph actually curves up. And it starts very, very big because 1 over something small is a very large value. It hits that point, and then it starts getting big again. So I see that my graph actually looks something like this, and it repeats itself the same in the other direction. And so we just need to look at the absolute value of these things that we're dividing by each other. And boom, we have ourselves our first cosecant wave. We see the fact that it was based off of the sine wave because the sine wave is traveling in the middle, and they do have some shared values and some shared attributes, but we're not graphing the sine wave, we're using the sine wave in order to graph the cosecant wave. So, not too bad. Let's take a quick look at number 3, something with a few more transformations on it. So number 3. First thing I'm going to do is I'm going to say, okay, my cosecant, I have to pull out this 2 pi, which leaves me with an x minus 2 plus 2. Awesome. I know this is going to be buddy-buddy with my sine wave, so I'm going to be looking at my sine wave with whatever attributes these have in order to graph my sine wave, which will allow me to graph my cosecant wave. So a couple things. Let's look at period, let's look at amplitude, and let's look at this has some shifts. I have a right by 2 units, and I also have an up by 2 units. So 2 transformations. My amplitude in this case is still going to be 1. My period is 2 pi over b, which is 2 pi over 2 pi, which is a value of 1, which means that I'm going to be having some really tightly packed waves here. If I repeat myself every 1, then my original scale was every pi. So first off, let's make sure everything is in value of 1. Okay. If I have a period of 1 and I'm shifting over by whole number units, I need to say, okay, this is going to be roughly 3. So let's split this into 2 more pieces. So that would be right here and right here-ish. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not exactly evenly spaced, but we get the idea. So I'm looking at this blue scale. I'm not really looking at the black scale. So let's take a look at where my sine wave would be. Okay. So my sine wave, I know, has been shifted to the right 2 and up 2. So my sine wave normally starts here, right 2, up 2. And it's going to repeat itself every 1 unit. So between these 2 blue points, it's going to go up 1, down 1, and hit this again. So it's going to go up, down, and hit that point. And so I'm going to be dealing with this wave right here. Let's draw a few more of these to see what the overall shape would look like. So every 1 value, I'm going to draw a tick. And we're assuming this is a flat line. Perfect. And so I know between each of these values, I go up, down, and hit it. Up, down, and hit it. So we do that all the way. And so we're going down to the 1, and we're going up to 3. Ideally, this should look exactly the same on every part of the graph. However, the sketching ability might need a little bit of work, but that's okay. Definitely that did not go all the way down to 1. There we go. Okay, so I've got my sine wave, and that's really all I need to graph my cosecant. So I'm going to go ahead and I'm going to draw my midline through this, because my midline is where I'm going to find my asymptotes. Now, my asymptotes for this thing is going to be where this function used to be 0. And if I take this and I shift it down, I know that through the midline is where the asymptote, or where the value was at 0. So every time it crosses that midline, I'm going to go ahead and draw an asymptote, which is not only at each period, but we'll notice exactly between each period, I have another asymptote. Okay, so those are just the periods. But again, I notice directly between each one of them, I have a second asymptote going directly through where the sine wave pings off that midline. And so this is going to be a super crowded graph. Awesome. So I have that. If this isn't confusing enough, just wait. So now that I've drawn my sine, I've drawn my asymptotes through all my zeros where it crosses the midline. I'm going to go ahead and put a point at each peak. I know I said this was going to be confusing. This is actually the easiest part. Once you draw a point at each peak, realistically these should all be along the same line, but you can see that my sketch kind of does this little warble thing. So I have a peak and a valley, so I got a point at each one of these. This is the easy part. I know that each one of these is going to curve up between these asymptotes, and because none of these are on my graph, I'm just going to draw a little derp right there. The next thing that I'm going to do is I'm going to say, okay, each of these is going to curve between its asymptotes. So I'm going to do something that looks like this. So in between each one of these red bounds, I'm going to draw a nice little tight curve. And boom, that is going to be my cosecant wave. Again, same principle as before, just repeated a little more tightly. And so that's going to bring us to, that it was cosecant. Let's try out secant. So secant, if cosecant was paired up with sine, secant is paired up with cosine. So I'm going to graph my cosine and then do the exact same thing in order to graph my secant wave. I'm going to find my period, my amplitude, and any sort of shifts. My period here is 2 pi over b, which is just 2 pi. My amplitude is 1. So I know that my cosine normally starts at 1, and every 2 pi it repeats itself. So let's see, right here it would be at its minimum point. Boom, so I have a cosine wave that looks something like that. And I'm going to go ahead boom, graph something like that. Procedure is exactly the same. Wherever I see a 0, I'm going to go ahead and pop down an asymptote. Wherever I see a max or min, I'm going to include those points together, because when I flip a 1 over 1, it's still a 1 over 1. Positive, negative, it doesn't make a difference. I also know that as I approach a 0, which is a small thing over 1, 1 over a small thing is a very big number. So the graph looks exactly the same as its counterpart, the cosecant. Just shift it over a little bit. Perfect. And there we go. That is our first secant graph. We notice it looks very similar to our original secant graph, just as opposed to starting slightly to the right of the origin or the y-axis, it starts directly on the y-axis. So nothing new, nothing crazy. So let's do number 7 super fast. What we're going to do is we're going to pull out that 3 pi. So if secant has a 3 pi and I have to factor that, that leaves me with x plus 2. Okay, this one's, if I have something like that, I don't think I'm going to enjoy graphing this. I know this is paired up with cosine. So my amplitude, which is 1, My period is 2 pi divided by b, which is 3 pi. So 2 pi divided by 3 pi is 2/3. This thing repeats itself a lot. I've also moved left by 2 units, and I've moved it down by 1 unit. So I'm going to have a cosine function with all of these attributes. Okay. I have a whole number shifts, which means I'm going to have to reorient this graph. If I have 2/3, how many 2/3 are going to be in pi? Well, let's take a quick look. If I take pi and divide it by 2/3, there's 4, almost 5. Okay. We're going to make an executive decision here, and we're just going to graph a small piece of this. We're not going to graph the entire span, because this is going to be a very tight graph. Actually, I'm going to keep these in values of 1. So 1, 2, 3. And I'm just going to count manually the 2/3. 4, 5, 6, 7, 8, 9. There we go. Okay. So if the cosine, which normally would be located at a 1, the midline would be at 0, 0. So I'm going to move the midline left by 2. Let's see. Okay. We're going to start with the midline that was normally at 2 pi, because I don't have room to move 2 to the left. So what normally would be starting at this point, I'm going to actually say I'm going to start at this 2 pi unit. Moving it left 2, so directly betweenish, betweenish, and down 1-ish. So this is where the new midline is right there. So normally it was 1 above that, so I'm going to go 1 above that. Boom. There we go. And so directly between each one of these, I know I'm going to go all the way down and all the way up. So let's see. Directly between, I should be something like that. Again, my midline's going right through here. So if between every one of these blue tick marks, I go all the way down, all the way up, all the way down, all the way up, all the way down, all the way up. That is a horribly drawn cosine function, but we get the idea. Every time it touches the midline, I'm going to draw an asymptote through it. And this is why we're not drawing very many of them. At the max and at the min, plot some points. I'm going to curve boom. We have ourselves a secant graph. So having seen that, what I want you to do is I want you to pause the video. I want you to try number 9, which is a slightly easier version of what we've seen, and go ahead, pause the video, unpause it when you're done, and see how well you did. Okay. So secant, this is paired with cosine. I know that this is going to be a slightly flatter version. The amplitude is 1/2, so this doesn't quite go up and down as much, it's squished. The period is going to be 2 pi, thank goodness, and it's going to be shifted to the right. That was originally going to be an S for shift right by 3 pi units. So much nicer. Okay. So let's take a look. My cosine, which normally starts at 1, is going to start at 1/2 because the midline is only going to go up 1/2. And every 2 pi units, it's going to be back at that 1/2. Directly between, it's going to be down at 1/2. Boom. So I got that. Oh, this is so nicer. Nope. that's too far down. There we go. Draw my asymptotes. Connect my maxes and my mins to my reciprocal graph. And then just bend. Now, here's the thing. My amplitude was 1/2, which means that this graph was much flatter. So is my reciprocal function. It's gonna be much flatter. It's still gonna curve up, but as opposed to those little U shapes, we're gonna flatten out each one of these U's. They approach their infinities half as fast. They still get there, they just get there half as quickly. Awesome. And there we go.